We're starting with exercise 12.2 MCQ. Before we begin, I want to give a brief explanation, just a brief explanation about what quadrilaterals are. Clear? So in this exercise, we will come across quadrilaterals a lot of times. Okay, these are polygons with 4 sides. Clear? With 4 sides. All right. So, or polygons, right? What are polygons? These are just plane figures that you can draw with the help of a line segment. Okay, these are plane figures you can draw with the line segment. So we talk about triangles. Anything that can be drawn with the help of line segments in itself are called polygons. Clear with what polygons are? Okay, anything you can draw with a line segment like this, anything. Okay, these are all polygons. Clear? Now, what are quadrilaterals? These are polygons with 4 sides. Now, this is a perfect example of what a quadrilateral is. All right. So what are quadrilaterals? Polygons with 4 sides. So any graph or any diagram or any figure with 4 sides, could be this, could be this. Okay, any polygons with 4 sides will be called quadrilateral. Clear? So we'll be coming across polygons, or we'll be coming across quadrilaterals. So whenever you come across quadrilaterals, please understand that we're talking about polygons with 4 figures, or we're talking about figures, okay, with 4 sides. Clear? Now this is an important figure. This is called a parallelogram. We're coming across this several times. Okay, parallelogram. Okay, by the term. So what is parallelogram? These are the properties of parallelogram. The first thing is that the opposite sides. What are the opposite sides? AD and BC are opposite sides. Okay, and AB and DC. Clear? These are opposite sides. Okay, they're opposite to each other in the sense. Clear? AD, what is AD here? This line. AD is opposite to BC, right? And DC, you look at this, DC is opposite to AB. Clear? And they are opposite, okay, and parallel and equal. Clear? That is the most important property of parallelogram. Parallelograms are quadrilaterals in which the opposite sides are parallel and equal. Clear? That means AD must be equal to BC. Clear? See, AD, look at this figure, this area. Okay, AD is equal to BC. Clear? Let me use a highlighter for this, maybe. Okay, so see, this line AD is equal to BC because they are parallel to each other. Clear? And then AB and DC, these are equal. Clear? So you will write this down. So remember this property. Okay, AB is equal to DC. This is an important property of parallelogram. Clear with this? Okay, now we are clear with what a parallelogram is. So clear with this concept. I'll be rubbing off all the ink, and now we'll be starting off again. Okay, so that is the important part about parallelogram. Now suppose you have a quadrilateral and you draw a diagonal. What is a diagonal? You draw a straight line. It is a straight line from one corner to another. From one corner to another. Now let me tell you what I mean by that. It is a straight line from one corner to another. So this, you look at this. This is one corner. This is another corner. This given straight line is a diagonal. Clear? From one corner to another corner. Same thing, A and C is a diagonal. Clear? From one corner to another corner. Okay? Or you can say from one corner to opposite corner. Okay, from one corner to, let's write this as opposite corner. This will make much more sense. Opposite corner, it should be opposite. Okay, so this is opposite. Clear? Opposite to one another. Clear with that? So this is a diagonal. So what are the diagonals here? DB, right? See, you see D here and B over here. See, D and B, the lined. Okay, and AC are diagonals. Clear? Diagonals. Okay. All right, so now this, we're clear with these diagonals. Now if you look at a quadrilateral, okay, can you see triangles? In a way, you look at this figure, can you see this figure? Do you see triangles in this? Yes, you look at this triangle, you look at this, you suppose you put a mark O here. Okay, I'm just putting a mark O here. You look at this, do you see triangle A, B and O, and B, O and C, D, O and C, and also D, O and A? Now there you can see 4 triangles. Apart from that, you can also just see so many triangles, right? You can even see the triangle A, B and C. You can also treat the other triangle, which is what? A, D and C. if you also want, you can also see one triangle there. There are two other triangles, two more triangles. What are those triangles? A, D and B, and the other triangles is C, B and D. So okay, whenever you have a quadrilateral, okay, you have a quadrilateral, okay, quadrilateral and quadrilateral, and you draw diagonals, okay, you draw diagonals, then okay, draw diagonals, okay, then we can come, or we can form triangles. Clear with that? All right, so that is an important part. Now we have a formula called area of a parallelogram. This is important. The area of a parallelogram is based into height, okay, based into height. Now this, what are the base that we're talking about? Remember, these are all the base, okay, DC, BC, AD and AD. These are all base. Clear? Obviously, for now, for this given diagram, okay, whatever I've represented here, obviously you can see DC as the base, but then you can flip, try flipping, okay, try changing the directions of the graph, right? So you're understanding, if you just flip the diagrams, then you'll come across when BC also becomes the base. Clear? So the area of a parallelogram is base into height. So we know what base are. It could be any of these, DB, DC, okay, BA. Let me just use a laser to print that. It could be DC is also a base, BC is also a base, BA is also a base, AD is also a base. Clear? So base could be anything. You can just flip, rotate, okay, as you keep on rotating. BC, if you rotate this, BC will come down, DB will go up, like that, okay? So you can just keep rotating if you're confused about that. But what is the height? How do you find out the height? So for some of you, you might be tempted saying that AD is the height, right? You can say this must be the height, or some of you may say BC must be the height. Some of you may think that AB is the height. Some of you may say DC is the height. But you look at all of this given, look at this diagram. The drawback is, you look, focus on the line AD. Is it straight? Is it straight? The first thing is it straight? No. So if you come across any diagram that is not straight, how do you measure your height? You have to measure your height by standing straight, right? So if you are slanting, if you're bending, will you be able to get your actual height? No. That's for that reason, what we do is we end up drawing a straight line like this, okay? So this will actually give us the actual height of the given parallelogram. So we actually found out the height for this case, right? From here to here we found out the height. Now what will be the height from here to here? Again, the same thing. You can just draw another straight line here like this. Clear? So this will give you another straight line. So this, okay, that means AO is the height and DZ is another height. Clear? AO is the height from A to D, and DZ, clear, DZ is the height from D to C and A to B. Clear with that? All right, so this is the important part, okay? And then lastly, let me remind you of one more thing, okay? The last important part. So whenever you're solving this question or this exercise, there are some words that you'll be coming across. Adjacent, opposite. Clear? Right? Look here, I've also written opposite. So at least you understand opposite, right? Opposite to each other like this. This is what we mean by opposite, right? If you're standing here and I'm standing here, we're opposite to each other. But what is adjacent means? We're standing side by side. Clear with that? All right, side by side. So tell me, okay, so see, opposite means we're standing across one another. Opposite or adjacent means we're standing side by side, okay? So you see this. So that means DC and BC are adjacent sides. Can I say that? Can I say that? Yes, right? They're adjacent. They're standing next to each other. The same way I can say DC and AD are also adjacent, okay? So just be clear with this. We may come across this, okay? Adjacent sides. You see, CD or DC is adjacent to what? AD. Clear? So this is what we mean by adjacent sides, okay? Standing next to each other. Opposite side means they're standing across each other. So be careful with that, okay? So that's why when we say diagonal, it's a straight line from one corner to another, two opposite corners. See, clearly mentioned opposite corner. So this is from one corner to another opposite corner. Clear? Now you may think that this is this may be another. You may think that this is an opposite corner, but this is not opposite corner. They are adjacent corner. Clear? Adjacent corner. Here B and C are adjacent corner, but B and D are called opposite corner. Okay, all right. One more thing. Now you look at this. One more, I'll clear this off. Now whenever you have these points, what are these points called? Remember I told them that they are corners, right? You call them corners, but then this word, okay, this particular point is also called a vertex. So what is a vertex? A vertex is a point where two lines will meet. That means from D if you travel you go to C, and from B if you travel and you go up to C, they will meet at a point, and that point is called vertex. The same thing for all these red points that you're seeing right here, all these red marks that I've done, these are all called vertex. Okay, so vertex is actually a point where two lines meet. That means I have this, so this given point is called the vertex. Clear with that? This point, for the case of this will be the vertex. Clear? Now these two, they are single, so this will not be a vertex. Clear? Because two lines are not meeting here. See here, this is not a vertex because two lines are not meeting. Okay, clear with that? So this is vertex, these are diagonals. So remember, okay, all these different properties and of a parallelogram. Now quickly we'll move on to this problem. Okay, the area of a quadrilateral ABCD. So let me name my quadrilateral ABCD. Remember, what is quadrilateral? It is a polygon with four sides. So I'm just taking a square. If you want, you can take something like this, or you can even take like this diagram, not a problem. As long as it's four sides, it's understood that we're talking about quadrilateral. Clear? Clear with that? You can take any polygons which has four sides. Okay, up to that. Now you have AB as 3 centimeter, BC as what? 4 centimeter. You have CD as 4 centimeter again, and you have DA as 5 centimeter. But what do you have? You have AC. So where is A and C? So you join that. So what does this become? Try to draw with a scale. Okay, mine I don't really have a scale right now, so it's crooked, but use a scale. So AC is what? 5 centimeter. So this becomes the diagonal. Now if you look at this, the quadrilateral ABCD, quadrilateral ABCD forms, what does it forms? It forms two triangles. Okay, I hope you're able to see what are those two triangles. Triangle ABC and triangle ADC. Clear? Now see, remember, okay, if you want people to understand that you're talking about a triangle, you put this sign, okay, this triangle, or you must have to write this. You have to write triangle ABC. Okay, you have to at least write this. Clear? If you want people to understand that you're talking about a triangle, because if you only write ABC, no one will understand what you're talking about. Clear? So you'll have to mention what you're talking about. So it's important, if you're talking about triangles, write the sign or write the spelling. Okay, so now we have two triangles, so we have all the sides of a triangle. So let's consider for triangle ABC. What is the side given here? We have AB is equivalent to 3 centimeter, BC is equivalent to 4 centimeter, and AC is equivalent to 5 centimeter. Now remember, this can be, we can replace this as our A, B as 4 centimeter and C as 5 centimeter. Okay, try to remember this. Okay, all right. Okay, so if you see now, if you look at this, okay, we're trying to solve this using Heron's formula because we're still in chapter 12, so it's understood that we're talking about, we have to form this. Okay, now why am I taking out two separate triangles? It's because if I'm able to find out the area of this triangle, right, and then I find out the area of this triangle and I add them up, then I can find the area. That means by finding the area of this triangle and by finding the area of this triangle and adding up, you by default, just not by default, but you're able to find out the area of a triangle ABCD. Clear? All right with that? So that's why we're doing that. Okay, okay, so you look at this. Therefore you have to find out S. What is the formula of S? A plus B plus C by 2. Clear? So I'm not writing down those. Okay, S is called what? Semi-perimeter. So you have to write this as 3 centimeter plus 4 centimeter plus 5 centimeter divided by 2. All right, so this will give you 5, 8, 12 centimeter by 2. That means this is 6 centimeter. Okay, clear up to this much? Let us go to the next slide. Okay, now we have S as 6 centimeter. Therefore let us find the area of triangle. we'll find the area of triangle ABC, which is what? Using Heron's formula. What is Heron's formula? S of S minus A, S minus B, and S minus C. Now you look at this. What is your S over here? Your S is 6 centimeter. 6 centimeter minus, what is your A? I have to go back once and check, okay? A is 3 centimeter. 3 centimeter. Now 6 centimeter again, minus, what is B? 4 centimeter. And then you look, what is your S here? 6 centimeter minus 5 centimeter, okay? So you use this, find the answer for this, okay? 6 centimeter into 6 minus 3 centimeter is 3 centimeter. 6 minus 4 centimeter is 2 centimeter. And 6 minus 5 centimeter is 1 centimeter. So you bring all of them together. Now before we proceed, you can write this as centimeter to the power 4, because how many times you're multiplying centimeter? 4 times. Now you look at this, you can open up this, or you can just leave 6 as it is, and you multiply 3 and 2, you get 6, okay? So what can you write this as? You can write this as 6 square into centimeter squared whole thing to the power square, right? So you can cancel this, and what do you get? You get 6 centimeter. Up to this much clear. We have already found out the area of triangle ABC. Now we'll have to okay, now let's go to the next slide. Okay, clear with this? We have found out for this. Now we have to find out for triangle ADC. Okay, now for triangle ADC, what do you have? AD is equivalent to 5 centimeter. Okay, AC is equivalent to 5 centimeter, and DC is equivalent to 4 centimeter. Therefore your S will be, so you can write A as 5 centimeter, okay? B is equivalent to 5 centimeter, C is equivalent to 4 centimeter, okay? See, it's not every time, it does not mean that A has to be 5 centimeter, okay? It's not like that. You can write A as 4 centimeter also if you want, okay? It's clearly up to you, okay? Here you can write AD, and you can say, you can, instead of writing this, if you want to write C, you write here C. You can write this as A also, not a problem, okay, with the notation. Clear? Therefore what is S? It is A plus B plus C by 2. So what is A? 5 centimeter plus 5 centimeter. C is 4 centimeter by 2. Okay, so this will give you 14 centimeter by 2, and that will give you 7 centimeter, because 2 into 7 is 14. Therefore area of triangle ADC is, okay, use Heron's formula. What is it? S of S minus A, S minus B, and S minus C. Okay, now you find out this. Okay, what do you get? S, what is S? 7 centimeter. 7 centimeter minus 5 centimeter, 7 centimeter minus 5 centimeter, and finally 7 centimeter minus 5 centimeter. Okay, no, sorry, this is 4 centimeter. Okay, sorry, this is 4 centimeter. Now you look at this, you open up this, you'll get this as 7. Just put centimeter, okay, 7 centimeter into 7 minus 5, 2 centimeter, 7 minus 5, 2 centimeter, into 7 minus 4, 3 centimeter. All right, so now you can see, right? Now you see centimeter, centimeter, centimeter. Just directly take it as centimeter to the power 4. 2 times 2 is repeating, so can I write it as 2 square into 7 into 2. You just multiply it, okay? Therefore what are you left with? You can cancel this, and if you cancel out this, you'll be left with 2 into root 21 centimeter square. Okay, all right, this is MCQ, so these are all steps. If you have watched the previous video, you'll be already clear why I got this. Therefore area of quadrilateral, that is quadrilateral ABCD, is equivalent to area of triangle ABC plus area of triangle ADC. So what did you get? Area of triangle ABC as 6 centimeter, and what did you get? Area of triangle of ADC as 2 root 21 centimeter square. I mean, both of them are square. Now you look at this. What is the common factor between them? What can you take common? If you take 2, what happens? What happens if you take 2? You can write this as 2 3, okay, plus you'll be left with 21, and you can take centimeter square outside, because again centimeter square is common to both. Okay, so you're getting this as 2 of root 3 plus 21. So that should be your option number. You go back to your option, okay, you see. So that means the answer should be option number 2 into root 3 plus this, okay. So that is your answer. Clear? For exercise 12.2, this should be your given answer, okay. Alright, so now we'll go with the second question of MCQ, okay. So the second question is this. The adjacent sides of a parallelogram are 3 centimeter and 7 centimeter. The ratio of their altitude is. Now what did I tell you about adjacent sides? They are sides that are standing next to each other, okay. So A, B, C, D, okay. So this is why it's very important that you remember the properties of parallelogram, right? So you look at this, the adjacent sides are 3 centimeter and 7 centimeter. So that means adjacent side means this is 3 centimeter, this is 7 centimeter. But what do you know about parallelogram? What is parallelogram? Opposite sides are equal. Opposite sides are equal. So you look at this. What is the opposite side here? What is the opposite side of 7 of BC? AD. That means AD will also be equal to 7 centimeter. Opposite side of DC is what? AB. And what is DC? 3 centimeter. So this will also be 3 centimeter. Clear up to this much? Now we're asked to find the ratio of their altitude. Okay. So do you know the ratio of the altitude? No, we don't know. We have to find altitude means height. Okay, so we'll have to find out the height. So the height from D and C, let's try to see, okay, the height from here to here, you can take this as, we can write this as AO, okay, or AO, and then the height from this to this, you can write this as DU, okay. You can name them anything that you want, okay. So these are the height. You can write this as AO and DU are the height. Clear? Now I want you to see here what are the base. The base are DC and BC. In our case, okay, I'm taking only DC and BC because we're taking the height from there, okay. Remember, okay, I'm not taking AD and AB as the base right now, okay. I'm just taking from DC and BC because we are taking this given point. We're trying to find out the height from this given point O to A, and we're trying to find out the height of this opposite side from U to D, okay. So this becomes the base. Clear? Okay, it's like a person standing down. If a person is standing here, then I'll be standing here. A person is standing here, so this becomes the height, and the place where his feet, okay, I mean the ground that the person's feet is touching, that this will become our base. Clear? So if you're standing like this, then this becomes your base. If you're standing like this, okay, if you're standing on the wall, then on the floor, then your floor will automatically become your base. Clear with that? This is just some example, okay. Okay, so this will be the base depending on wherever your foot is on, that becomes your base, okay. So keeping that in mind, let us now try to find out something interesting, okay. Here you'll have to say, now what I'll do is I will say let DC be H, okay, H1, and BC be H2, because we're talking about the base, we're talking about the height, okay. So height 1 and height 2. Therefore the area of a parallelogram is what? Of a parallelogram, what did I tell you about the area of a parallelogram? It is based into height. Clear? Now for base DC, okay, DC is equal to 3 centimeter. All right, so this is what we have for the base, okay. Now similarly, so that means therefore the area of parallelogram for this, okay, will be base. What is base? Base is DC, okay. It's DC into height, okay. Height, we don't know what the height is, okay. Instead of that, let's just write this. I'll first write the notation. DC into, what is the base for DC? If you take base as DC, the height is AO into AO, okay. So you go to the next page, we'll go. So what is DC? DC is given as 3 centimeter into, what is height given as H1. Now area, will just name it as area, okay. Now we have another base, right? Area of parallelogram, it's going to be parallelogram. What is the base going to be? It is base into height. So what is the base over here? I'm going to consider this BC as the base, okay? So I'm considering BC into DU. Now what is BC equal to? 7 centimeter into what is DU? H2. Okay, therefore the area of a parallelogram are both going to be same, right? Since we are talking only about one parallelogram, since we are talking, we are referring, okay, to one parallelogram, okay, parallelogram, the areas are going to be same, okay, the areas will be same, the areas will be same. Clear? So that means what you have, I can say 3 centimeter is equivalent to H1 and 7 centimeter is equivalent to H2. Clear? So finally, what is going to the ratio going to be? 3 centimeter by 7 centimeter, you bring it this side and you have H2 by H1. Clear? So you can just cancel out. So that means, therefore, you can write this as H2 is to H1. Since we're talking about is the same thing as 3 is to 7. So that means your option is going to be A. Clear? So you go back, this is your given ratio, okay? So this is going to be your answer. Okay? Alright. So okay. Alright. So okay. Okay, so this is actually going to be okay. Alright, so according to your textbook answer, what happens is that you have to write this as H1 by H2, okay? So this will become 7 centimeter by 3 centimeter. So you can just cancel centimeter. So H1 is to H2. This is the same thing as 7 is to 3. So your option is option number B. Okay? Alright. Okay, so we're taking the ratio of height 1 with height 2, okay? Okay, I hope you're clear with that. Height 1 with height 2, H1 by H2. Okay, just put this. Alright. So this is the given answer. Okay. So we'll go with the next question. So see, the area of a regular hexagon of side axis. Now, what is a hexagon? It is a polygon with 6 sides. 1, 2, 3, 4, 5, 6. Okay, let me try to draw this a little bigger. Okay. So maybe for the previous question, maybe you'll not get only for class, maybe for this textbook, they have given you both the ratios, but maybe for other exams, they will not give both this given, okay? Ratio, because actually there's a possibility that 3 is to 7 could also be the answer, or 7 is to 3 could also be the answer. But in the textbook answer, they have given 7 is to 3. Now you look at this, okay? What is a hexagon? A hexagon is a polygon with 6 sides. Clear? So now, if you can take, so you try to take the diagonals, all of it. Okay, so how can you draw a given triangle? Is by just drawing all of this. Clear? These are all the diagonals. Okay, so you have this diagonal. So that means this is A, B, C, D, E, F, and you can put the middle point as 0. Gift. Now you read the question. The area of a regular hexagon of side X. So that means the sides are going to be X. Clear with that? The side of a hexagon are going to be X. But there's an important you must understand this, okay? The important thing is, if you draw a triangle, okay, if you're able to draw diagonals like this, and if they intersect at this point, what happens is that the side of this, okay, all these triangles are going to be the same. That means the triangles formed by a hexagon is, you can write here, the triangles formed by joining the diagonals, okay, the diagonals. So what are the diagonals? From one opposite vertex. So from here to opposite, this is opposite, from this to this is opposite, and from this to this is opposite, okay, they're opposite to one another, okay. By joining the diagonals are the triangles formed by joining the diagonals of a hexagon are equilateral triangle. Clear up to this much? So what happens if it's an equilateral triangle? Since it is an equilateral triangle, all sides of a triangles are same. Okay, so you see AF is one side. So what is going to, let's just consider one triangle, okay, there, see, this is, I'm going to consider triangle AF and O. That means this is also X, this is also X, right? See, all these triangles that you see are all equilateral triangles, so these are also X, X, everything is X, okay, all right, clear with this? Remember that, okay, equilateral triangle, so these are all X, clear up to this much. Therefore, what is area of an equilateral triangle? Area of equilateral triangle, I gave you in the first, it is √3 by 4 a square. Clear? Clear with this? Okay, what does a square means? Here a actually means side, okay, a means side, remember that, okay, a is side square, it's 3 by 4 side square. So when the side, okay, let me just write here, when, I'm not writing in a systematic order because this is just MCQ, okay, so it's important that you understand that. So when the side is X, then therefore the area becomes 3 by 4 X square. Clear? But you look at this, therefore the area of a hexagon. Now you see what is going to be the area of a hexagon. How many equilateral triangles are there? You count. This is 1, 2, 3, 4, 5, 6 equilateral triangles. So if you are able to find out the area of all of these 6 equilateral triangles, what will you get? You will get the area of the entire hexagon, right? Let me just use a laser point. If you're able to find the area of all of these equilateral triangles, all of these triangles, okay, what happened? You'll be able to find out the area of the entire hexagon. But since all of these triangles are equilateral, that means they're all or more or less the same. What do? We just write this as, how many triangles are there? 6 triangles. So 6 into 3 by 4 X square. So this will become 2 and this becomes 3. That means the answer is 3 by √3 X square by 2. Clear with this? That means this is your option number C. Clear? Okay, you must understand this hexagon, okay, the properties that the triangles formed by a hexagon are all equilateral triangle. This is the biggest clue that you're going to have, okay. Now since this is an equilateral triangle, all the sides are going to be same. So what is the side of this given hexagon? The side is given as X. So that means this, first consider these sides, okay. Now after that you draw the diagonals and you form a triangle. So then these triangles are all equilateral, so all the sides are also going to have the same measurement, okay. Clear? So the answer will be C. Now we'll go with the last question. Okay, this is a given question. You look at this, but before this, okay, I don't know, maybe your question is wrong or your textbook answer is wrong, okay, because in the textbook they have given it as 102 centimeter, but just by following this question, actually the answer is supposed to be 51 centimeter square, okay. So I'm not sure whether the question is wrong or the option is wrong, but in the textbook they have given it as 102 centimeter. You just try to clarify, okay, from your teachers, from your maths teacher, okay. So this is a parallelogram. Now just remember, okay, a parallelogram, one of the diagonals of parallelogram. Read the question, diagonals. So what is it? The diagonal, okay, wait, the diagonal, this is the diagonal, right? Only one, okay, not both. It's given only one. So you can take AC or you can take AB if you want. in my case I'm going to take 15 this, okay, I'm going to take this. Now this is the question, okay, the perpendicular, see, and their perpendicular distance of the diagonal from the opposite vertex is 6.8 centimeter. All right, this is where you'll have to pay attention, okay. What do you understand by the word perpendicular? If you have a line like this, we say that the line is perpendicular if you draw a straight line here, okay. So this given line, this line is the perpendicular line. All right, perpendicular line, okay, this is perpendicular line, clear? A straight line that crosses through another straight line. So what is it? And the perpendicular distance of the diagonal. So the perpendicular distance of the diagonal will be from here, right? The perpendicular distance from the diagonal from the opposite side vertex. So this is the opposite side vertex. So from here, okay, so this is what the question means, from here to here. All right, this is given as 6.8 centimeter, clear? This is the perpendicular distance of the diagonal. That means we have to take a straight line from the diagonal, clear? Perpendicular distance of the diagonal. So a straight line from the diagonal to the opposite side vertex. What is the vertex? This is the point. So the opposite side of this is this, okay. It could be this. Another you can draw is it's the same line you can draw from here to here, okay. This, all right, this is both 6.8.4 centimeter, clear with that? Therefore we can consider, you see, okay, what can we consider? We can consider triangle, you see, ABC and what triangle? ADC, clear? You see triangle ABC. Therefore you look at triangle ABC, okay. So what is the base of the C? So the triangle is like this, right? You see, this is the triangle B and A and C. So what is the base? What is this triangle? 15 centimeters. So if I want to find the height of this given triangle, I have to take this, okay. What is the height? The strongest or the lower, from the highest point of any figure will become the height, right? So even you, when you measure your height, you don't measure your height till your shoulder, right? You'll have to take up till your head. So you take it to the highest point, clear with that? All right, the height is the highest point, right? So this is the height, but we already know the height. This is given as 6.8, clear? Therefore let's consider, therefore, triangle ABC, okay. So for triangle ABC, what is the base? The base is AC and this is equal to 15 centimeter. And what is the height? The height is, I'll write this as AO, okay. So I'll write this height is OB and this is equivalent to 6.8 centimeter. Now what should come? So how do I find the area of this triangle? You already know the base, you already know your height. That means you have area of triangle ABC. You already have a big clue. What is that? Area of a triangle ABC. Whenever you have the height, remember we're using Heron's formula only if we don't know the height. So if you know the height of a triangle, then why waste time? Just use this formula. So what is the base? 15. And what is 15 centimeter? And then what is the height going to be? What is the height going to be? 6.8, okay. It's going to be 6.8 centimeter. Now you take cancel out with this. 2 3s are 6 and 2 4s are 8, right? 2 4s are 8 and you have centimeter, okay. Don't forget the centimeter still remains. There was no need of writing a centimeter. I have not got it here. All right, now you take the multiplication of 15 into 3.5, okay. Okay, I think yes, 15, okay, 3.4, okay. The textbook answer is going to be correct, okay. That means I have done something wrong when I was doing the calculation earlier. 3 into 3 ones are 3 and then 4, so what is left? 51. So this is 51 what? Centimeter square, because you have one more centimeter here, don't forget, okay. So we already found for triangle A, B and C. Now what we have to find out? We have to find out the triangle A, D and C. Clear with that? We have to find out for triangle A, D and C, okay. So you go next. Therefore for triangle A, D and C, what is the triangle A, D and C? AC is the base and DO is the height. So AC is the base, and this is equal to 15 centimeter, and DO is the height, and the height is what? Equivalent to 6.8 centimeter. Therefore, the area of triangle ADC is equivalent to half into base into height. So what is the base here? 15 centimeter. What is the height here? 6.8 centimeter. So you cancel out 2, 3.4. Do the multiplication, it will still be the same. 51 centimeter into centimeter, centimeter square. Now you have, see, you have area of triangle ADC, and you also have triangle of ABC. You have triangle ABC and then triangle ADC. So after you found out the triangle, what are we asked to find? We are asked to find the area of parallelogram. So what do we do? Very simple, right? You just add them up. If you add this area of this triangle and add the area of this triangle, you will get the area of the entire thing, right? Clear with that? So therefore, area of parallelogram, okay, parallelogram means you take area of triangle ABC plus area of triangle ADC. So what do you get? This area of triangle ADC is 51 centimeter square. Area of triangle, this is also 51 centimeter square. 51 plus 51, 102 centimeter square. Clear? So let us see what is the correct option. That is option number B. Okay, it's the textbook answer is correct. That means when I was solving earlier, I have made a mistake with my with some, I think, values. Okay, so this is the correct answer. Okay, so we shall end it here.